Hello there and welcome to video number 132. This is the last video in the ratio and proportion section, and this one is on ratio and changing ratios. So the keywords I've got for you are ratio and parts. Hopefully by now you do know what a ratio is because you're watching this particular video, which is really tricky. But a ratio is a way of splitting something up, and the parts are the numbers that are in the ratio. So the method states that these sorts of questions are really tricky. You do need to identify the initial given ratio, and it changes after some stuff happens to it. But in essence, all you need to do is these three things. Write the ratios as equations. Turn the ratios into fractions, form and solve the simultaneous equations. You don't always get simultaneous equations, depends on the information you've been given in the question, but it more than likely will be some simultaneous equations for you to solve. Anyway, let's crack on and try question number 1. The ratio of red to blue counters in a bag is 1 to 2. 8 red counters are added, that's the stuff that's happening. Now the ratio of red to blue is 7 to 6. So the ratio has changed from one thing to another. How many counters were in the bag originally is what we've got to calculate. So let's set up this ratio as an equation. So R to B is equal to 1 to 2. There's our initial ratio equation. And then the second one, we've got R plus 8, because 8 red counters have been added, to B, nothing's happened to B, is equal to 7 to 6. Now, turn them into fractions. When you turn them into fractions, you put the second part of the ratio underneath the first part of the ratio. So you've got R over B is equal to 1 over 2. And then you've got R plus 8. And these are separate things, by the way. R plus 8 over B is equal to 7 over 6. All right? So this is one equation. This is another equation, right? They're simultaneous equations. So 2 times by R, do the cross multiplication method here. 2R. And then 1b, 2r equals 1b, so 2r equals b. And then in this one, we've got 6 times r, which is 6r, and 6 times 8, so plus 48, is equal to 7b, 7 times b. All right, now what I'm going to do in this instance here is I'm going to multiply this b by 7, that's going to be 7b, and then this is going to be 14r, because that means that the b's are the same. All right, the amount of b's I've got in each equation. So I can make 7b equal 7b, which would be making this expression 6r plus 48 equal to this term 14r. Okay, now that's just an equation that's got rid of the b term, and I can just solve to find r. So 6r taken away from 14r is 8r. That equals 48. And then I'm going to divide both sides by 8. That gives me 6. r equals 6. If R is 6, that's lovely, we know that, but we wanted to know how many counters there were in the bag originally. So if the original ratio was 1 to 2 for R to B, right, which it is, then we need to get to 6. So we can see that 1 times by 6 to get 6, so we times 2 by 6 to get 12, and then we add those parts together to get 18 counters. All right, pretty tricky question, all right, but it's doable using that method. Okay, let's have a look at question number 2. So, there are 44 blue cars in a car park. This time we know the number of blue cars, which means we can work out the number of red cars in the initial value here. So we won't need to set up a simultaneous equation here. The ratio of blue to red is 2 to 5. The ratio changes to 9 to 20 when an equal number of each colour car come into the car park. Work out how many cars come into the car park. So we need to work out that unknown value. All right, and in maths, when we don't know a value, we refer to that value as a letter. I'm going to call that letter X in this question. So first of all, we are going to write down R to B. To start this problem off, R to B is 2 to 5. And then we're going to scale that up because we know that R is 44. And if we multiply by 22, because we see that 2 times by 22 gives you 44, we can multiply by 22 on this side. That'll give you 110. All right, so there are 44 blue cars. I've written that the wrong way around. I'm not going to start again. I'm just going to change that. All right, 44 blue cars, blue to red, B to R. That would be a horrible mistake to make. Yeah, blue to red. Now we know how many blue cars there are. We know how many red cars there are. All right, and that's great. So we can use those numbers in our question. All right, or in our ratio equation. So we know the ratio changes to 9 to 20. All right, so let's set up an equation, a ratio equation. And let's have 44 plus a certain number of cars that come into the car park, all right, is in the ratio of 110 plus the same number of cars that come into the car park, so we use the same letter X, right, is equal to 9 to 20. All right, now let's write the second term or second expression underneath the first expression there to turn it into fractions. So 44 plus x over 110 plus x is equal to 9 over 20. And then cross multiply. So if we cross multiply 20 times by 44 is 880 plus 20x is equal to, and then cross multiply this, 990 plus 9x. There's our equation that we've got, which we need to solve. So I'm going to go up there with it and carry on with my working. So I'm going to take away the 880 from this side and from here, 880 from here. So 110 is what it equals. I'm going to take away 9x from this side. That's going to give me 11x is equal to 110. Okay, and that leaves me with x is equal to, if I divide both sides by 11, x is equal to 10. So I know that there were 10 of each colour car that came into the car park. So work out how many cars came into the car park. 20 cars. Because I know that it was 10 of each colour that came in. Alright, so it could be that you had to work out the total number of cars that were in the car park now or something like that. Just add 20 onto the initial 154. Alright, so that'd be 174 cars that are now in the car park because 20 extra are there. But that's the answer that we need because that's the question that we've been asked. Alright, so not a simultaneous equation, but it's still setting up equations and solving those equations. Right, third and final question. Let's have a look at this one. So the ratio of students to teachers on a trip is 4 to 1. If 6 students and 6 teachers leave, they would be in a ratio of 10 to 1. So stuff happened, the ratio changed. Find the original number of students and teachers on the trip. Okay, so it's just setting it up the same way, but yeah, thinking of things logically as we go through. So let's say that students to teachers is equal to 4 to 1. Okay, and that's our initial ratio, and our changed ratio is students minus 6, so S minus 6 to T minus 6, 6 of each have left, then that would equal 10 to 1. Okay, that's hypothetical if that's happened. It doesn't say it's happened, it's hypothetically happening. So let's set these up as an equation. So you've got S over T is equal to 4 over 1. All right, and then this one would be S minus 6 over T minus 6 is equal to 10 over 1. S equals 4T, and S minus 6, if you multiply it by 1, I'm not going to change either of those terms, equals 10T minus 6D. 10 multiplied by T is 10T, 10 multiplied by minus 6 minus 60. So now we've got those equations, we could make this one equal to S actually, right? Just take 6 away. So S equals 10T, take away 6 from minus 60 is, or sorry, adding 6 to minus 60 is minus 54. Nearly made a mistake there. Didn't though. And now we've got both are equaling S, so I can make the S equal the S, and therefore 4T equals 10T minus 54, and then I can solve this simultaneous equation. So 54, add 54 to both sides, it's 54. There's my positive number that I'm going to need because it's a contextual problem and it wouldn't make sense if it was negative. Take away the 4T, that's going to be 6T, and that's then dividing by 6, which is going to give us 9. T equals 9. So the number of teachers, and find the original number of students and teachers on the trip. So the number of teachers would be students to teachers was 1 and 4, 4 to 1. And then in this one, we got 9. So times by 9 times 4 by 9, 36. So that, adding those parts together, will give you 45 students and teachers. So they are, we could refer to them as people. There they are. Teachers are people too. All right. Thank you so much for watching this video. I've enjoyed that, doing all of that. It's some good maths, but it is very tricky to get your head around. Have a good practice at it. Click the link in the description and practice that way. You'd be unlucky to find anything harder than that in the ratio section, I think. I don't think there's anything harder than that. But yeah, be lovely to one another. Hope you enjoyed watching this whole section of stuff and that you continue to improve your mathematical skills. Let me know if you're working hard, and let me know what you're doing. Put some comments for me to read, and I'll reply to you about things that you comment on. All right, that's it. On to the next section. Take care of yourselves. Bye bye.